Thank you. So in the previous class, we had a discussion about CPI, SPI, and the I2C bus, which are going to act as a onboard communication interfaces. So next we talk about what are the external communication interfaces, means how the embedded system is going to communicate with the external world, obviously through a communication channel. So channel may be wired or a wireless. So here we are going to talk about the wireless communication. And the example is first one is infrared. IR, we may say IR rays. What we are going to consider, that is nothing but the frequency selected by these devices, this communication channel. Okay, so infrared, and sometimes it is labeled as IRDA. IRDA. So what are the specification of this bus? So infrared IRDA is a serial communication interface. It uses half duplex, nothing but through the channel, through the wire. Okay, through the channel. Here the signal will be transmitted only one time. Okay, it is only performed. It may be receiving or sending task, not both the tasks at a time. Half duplex. Then line of sight means it is purely on particular line of sight based wireless. It is not spread over 360 degrees. It is only at a particular angle it is going to approach the line of sight based wireless technology for data communication between devices. So most thing it is used, we are known to these IR devices. Those are nothing but television remote devices, remote control devices. So it is used from the olden days of communication. So this one is the old technology which was introduced to communication with embedded device and external devices connected to it. So the remote control of television or the VCD player or other remote controlling components or devices works on infrared data communication principle. And it supports point-to-point and point-to multi-point communication. So some of the mobile phone also uses this infrared technology. Still, they are going to provide the facility of this olden days communication concept. So this is going to act as a point-to-point communication or point-to multi-point communication, provided all devices involved in the communication are within the line of sight. If we go for multi-point communication, all these devices come under that line of sight concept. The typical communication range for this infrared lies in the range 10 centimeter to 1 meter. So the range it is covered by this infrared communication channel, it is up to 10 centimeter to 1 meter. The range can be increased by increasing the transmitting power of the infrared device. So by improving the device power, transmitting power, we can increase the range what it want to cover. So depending on the speed of data transmission, the infrared is classified into SIR, MIR, FIR, VFIR, UFIR. Nothing but the SIR, serial infrared, and the speed is covered in this category. It is 9,600 bits per second. 9,600 bits per second, the data will be communicated, and it is a serial type, and it is up to 100 15.2 kbps. Okay, means from 9,600 to 11,520. 11,520 bits per second, the data rate will be there. Okay, then that much bits are sent or communicated over the channel. So that type of rate comes under serial infrared transmission media. And medium, that is MIR, the medium range, the speed is about 0.576 megabits per second and up to 1.152 megabits per second. 4 Mbps speed is achieved in fast infrared transmission media, and 16 megabits per second is comes under the transmission media that is known as very fast infrared transmission media. And here the infrared, it is designed up to from 9.6 kbps to 16 megabits per second, from 9.6 kbps to 16 megabits per second. But extra thing which is added by improving the transmission power and the improvement in the infrared technology, they have working on the 100 Mbps speed, which is known as ultra fast infrared transmission media, UFIR. It is up to the target is the data rate is of the speed is of 100 Mbps, megabits per second, which is under development. The infrared, obviously, it is going to use what? The one is transmitter, one is a receiver, where the transmitter is designed using a LED, which is going to support the infrared frequency. Is the IR source for transmitter, and at the receiving end, a photodiode acts as a receiver. So if you observe the communication between television and the television remote, so at the receiving end, that is television, and the sending end, it is the remote control. So in the remote control, we are going to use the LED, and in the photodiode is used at the receiving, that is television screen or television panel. So this is about infrared IR device and its brief introduction with the help of what is the infrared and where it is used and what are the types of data communication medias with the speed quantity. Then comes the next advanced technology, is Bluetooth. So we are all familiar with this Bluetooth. Bluetooth is a low cost, low power, short range wireless technology for data and voice communication. Obviously, we know this one. So it is a low cost, low power. So the power usage is minimum, and short range. So range is also minimum. Shorter distance it is going to cover, and it is a wireless technology for both data and voice communication. So Bluetooth operates at 2.4 gigahertz of the radio frequency spectrum. So it is going to have the frequency, the speed at the frequency allocated for this Bluetooth, it is 2.4 gigahertz. It supports a data rate of up to 1 Mbps. 1 Mbps is used, and a range of approximately 30 feet for data communication. So the Bluetooth enabled devices are going to communicate up to the distance of 30 feet. Up to 30 feet. Means it is nearly 8 to 10 meters. 8 to 10 meters. And the data rate per second, it is capable to transmit 1 megabits. 1 megabits. Bluetooth communication also has two essential parts. It has two essential parts. One is physical link part and another one is a protocol part. So what this physical link part is, the physical link is responsible for the physical transmission of data between devices. Means this physical link, whatever the data communication is going to happen between the devices, it is known as physical link. And this protocol part, it is responsible for defining the rules of that communication. Means this device is going to have two parts. One part is working on what is the rule, another part is working on what are the devices it has connected. So communication between devices, it is maintained by the physical link, and how the communication has to be done, the protocol. So those are defined by this another part, that is protocol part. And the same parts are also available in infrared. Infrared is also having both essential parts, that is physical link and protocol. So protocol is for defining the rules and physical link is for communication with devices. The Bluetooth communication IC holds the stack. Each Bluetooth device will have a 48-bit unique identification number. Unique identification number. So Bluetooth communication follows packet-based data transfer. So what this one is going to have, how the physical link has, the physical link has each Bluetooth device has its own stack memory. It has its own stack memory, and all those stack memory is nothing but IC, which has, and each Bluetooth device, it has its own unique identification number. Bluetooth ID, what we are going to say generally, it has a size of 48 bits. And it is a unique one. For each Bluetooth device, unique ID number will be there. So this is going to use the data transfer of type packet. So packet by packet, the data will be transmitted over the channel. Bluetooth supports point-to-point, one device to another device, and point to multi-point. Means it may communicate with one point to multiple point. Okay, device to multiple devices, that is nothing but broadcasting. It is possible using this Bluetooth technology through wireless communication. Obviously, so nowadays we are going to observe point to point, nothing but obviously nowadays we are going to use many devices in the beginning, from your earphone, wireless headphone to the mobile equipment. It is everything is designed using a Bluetooth. Nowadays we are observing the Bluetooth enabled speakers, mobile phones, Bluetooth enabled headphones, Bluetooth enabled earphones, Bluetooth enabled printers, okay, Xerox machines, photocopy machines, and everything is nowadays where it is designed with the help of Bluetooth wireless communication technology. Here, the Bluetooth device must support the generic access profile, defines the requirements for detection and connection. So it is going to use some of the activities. For using this Bluetooth technology, the Bluetooth must support all these things. So what are the things to be supported by this Bluetooth device? So the activity is done by this Bluetooth device. First, it is going to perform generic access profile. Means it is going to find the nearby devices, that is nothing but detection, and it is going to communicate by connection. So it is the responsibility of the Bluetooth device to detect the Bluetooth device around it and connect each other. Then it has to support the file transfer. Means if from one Bluetooth to another Bluetooth, if we are transferring the data, so the data file transfer profile. So for file transfer, then it has to have the human interface devices. We're going to call that as the HID for supporting human interface devices. Okay. So these are the things. Human interface device, nothing but what? These are the headphone. Okay, for Bluetooth transfer, we are going to use from mobile phone to a laptop through Bluetooth. So file we are going to transfer. It may be image, or it may be video, or it may be audio. So file we need to transfer. The human interface devices, nothing but nowadays we have Bluetooth watch. Okay, Bluetooth headset, Bluetooth earphone, and there are so many human interface devices what we are designing with the help of this Bluetooth technology. So all these Bluetooth concepts must be supported by this device. That is data channel connection, file transfer, and all human interface activities. Okay, so this one is about Bluetooth technology. Only brief introduction is there, not in depth. Okay, in model 1, only introduction part is there. Then comes the next wireless communication, which is much better than this Bluetooth or infrared. So it is Wi-Fi, or it is wireless fidelity. So what is this Wi-Fi? Wi-Fi is the popular wireless communication technique for networked communication of devices. When devices are come under a network, so that complete network communication will be happen through wired or wireless. So through wireless, we may go for LAN, local area network, or for wireless, we may go for the Wi-Fi, wireless communication concept, that is wireless fidelity. So Wi-Fi is intended for network communication. It is mainly designed for network purpose. So network is a wireless thing, then we are going to use Wi-Fi. Then it supports internet protocols, IP protocols. The Wi-Fi based communications require an intermediate agent. So here Bluetooth, it is not going to use any intermediate agent, any external device it is not going to use. There is a point-to-point or point-to-multipoint communication directly between two devices. But what is going to happen with the Wi-Fi? It requires a Wi-Fi router which is going to act as an intermediate agent, or a wireless access point to manage the communication. So this type of communication, Wi-Fi, uses an agent between two devices. Means the device 1 and device 2, if we are going to connect through this Wi-Fi, so both the devices are connected through one router. That router is called as Wi-Fi router. So Wi-Fi enabled devices contain a wireless adapter for transmitting and receiving data in the form of radio signals through an antenna. The hardware part of this is known as Wi-Fi radio. So whatever the antenna concept, it is introduced in all these Wi-Fi enabled devices. That antenna, that part is known as, the physical part is known as the Wi-Fi radio. So this Wi-Fi radio, the transmitting and reception of data is going to happen. And it was from 2.4 gigahertz to 5 gigahertz. It works on the speed of 2.0 gigahertz to 5 gigahertz. For communicating with the devices over Wi-Fi network, the device, when its Wi-Fi radio is turned on, first it is going to perform the detection, that is nothing but searches the available Wi-Fi network in its surrounding area, and it lists out, that is nothing but service set identifier. So as we are going to observe in the Bluetooth devices, each Bluetooth device is having its own unique ID number. Similarly, these Wi-Fi devices are going to use a unique ID number, that is service set identifier of the available networks. And if the network is security enabled, a password may be required to connect to a particular device. Means obviously we are going to observe this condition also with respect to, that is a detection and connection concept in the Bluetooth also. So while connecting, they need the password for security enabled devices only. So unsecured devices are going to connect easily, where the security enabled devices need extra process, that is nothing but authentication through password matching. Okay. So service set identifier has to accept the connection through password, that is security enabled concept. So these are the introduction part of this Wi-Fi. Then we move towards the last concept. It is the ZigBee technology. So the ZigBee technology, it is a low power, low cost wireless network communication protocol. So this one is not so familiar with all of us, because we are familiar with Bluetooth, infrared, and Wi-Fi in our day-to-day life. We are using those communication concepts, okay, devices. But ZigBee, it is most used in industries. So it is a low power, low cost wireless communication protocol. So its specifications support a robust mesh network containing multiple nodes. If you come to this network, we have the network architecture, and it is going to support mesh network, and it operates worldwide at the unlicensed bands of radio spectrum, mainly at 2.4 to 2.484 gigahertz and 9022 to 928 megahertz and 868 to 868.6 megahertz. These are the frequency ranges supported by this ZigBee. ZigBee supports the operating distance up to 100 meters and a data rate of 20 to 250 kilobits per second. 20 to 20 kilobits bps to 250 kbps. Okay, this one is the data rate, and the distance covered by this ZigBee, it is 100 meters. Then the network, it is also a mesh network. It is going to support the network. It is having three concepts. The three main working nodes, and those nodes ZigBee is having. The first one is the ZigBee coordinator. That is nothing but ZC, what we are going to illustrate, or you may say it is a network coordinator, and it has the responsibility to act as the root of this ZigBee network. So this one is the main responsible node in that particular network. In the ZigBee network, the main role it is assigned to this ZigBee coordinator, that is ZC node. It is responsible for initiating the network, and it has the capability to store the information about the network. Means the complete network information, it is available in this node, and it has the responsibility to initiate the network operations. Second node is ZR. It is known as a ZigBee router. ZigBee router, that is full function device. The responsibility assigned to this one is, it is used for passing information from device to another device or to another ZR. means the routers are going to connected with ZC as well as the ZigBee routers are connected with device. Okay. Then the device is going to send or receive the or end device. It is known as ZigBee end device. Okay, and it is going to be known as the reduced function device. Reduced function device. This device containing ZigBee functionality for data communication. ZED device. It is the end device in the network where the data will be sent or data will be received from one device to another device, and this is capable to communicate with only ZR, that is ZigBee router, or the ZigBee coordinator. It may directly connect it to ZC bypassing the ZigBee router, or it may communicate with another device through this ZR. We can observe here in the diagram here ZC. It is the device which is having the responsibility of initiating the network as well as information about the network. So this one is the main part of this network. ZC is the main part, main controlling part. Then here to communicate with one device to another device, the end device is called as ZigBee end device. ZigBee end device. Here you are going to observe there are so many nodes act as a ZigBee end devices, and these devices are going to communicate each other through or directly through ZC or through ZR. Through ZR, they are going to communicate. So what is this ZR? It is the responsible element which is used for transferring the data from one device to another device. There is nothing but it is an agent between two devices. Okay. So the communication may be happen through this one device to another device through ZigBee router or directly from ZigBee coordinator. So these are the things what we had discussed in today's session. So here we discussed about 4 wireless communication technologies. One is infrared, another one is Bluetooth, another one is Wi-Fi, and last one is ZigBee. So these are the 4 wireless communication techniques are covered in your syllabus. This is kind of your model number 1. So in the model number 1, we had a discussion about the embedded systems. That is model number 3, embedded system components. We had a discussion about embedded versus general computing system, then classification of embedded systems, then major applications and purposes of embedded system, elements of an embedded system with a block diagram, the difference between architecture, then we have instruction set, and then we have the architecture, it is hardware and Princeton architectures. Then we have memory utilization, how the data will be stored in the memory, that is big and little endian format. Then we had a discussion about memory, how only with respect to ROM and RAM types, read-only memory or random access memory. Yeah. Then we discussed about sensors, actuators, and optocouplers. And we have this introduction about communication interfacing devices such as high-speed bus, SPI. Then we have Wi-Fi, infrared, Bluetooth, and ZigBee. So this one is covered in model number 3. and 2017 scheme students. How are there in the 17 scheme syllabus? Maybe 3 students are there. Those are, you just raise your hand. 17 scheme. One is Videsh Swami, then Deepa Jadhav and Purnima, 17 scheme. Only 3 members are there. Okay. For you, this model number 3, it is same, but few concepts are added. Few concepts are more. 18 scheme. So 18 scheme is a reduced one. For you, some more interfacing components are introduced for you. That is LCD display, so sensors, actuators, and optocouplers. So in that concept, the 18 scheme is have only the definitions. For 17 scheme, we have examples in the sensors. So what are the examples? So according to you just go through your syllabus, and I will send notes regarding that one. Okay. So you just go through your syllabus, which is a little bit more compared to this 18 scheme syllabus. Okay. So I will tell. So I will tell what are the things. You just go through one, and I will share the notes regarding those concepts. Okay, sensors and got output devices. In the output devices, where for you example of LCD display is there. LCD display and stepper motor, I think so. Stepper motor is there as a syllabus. Okay. Regarding sensors, let me go through that your syllabus. Okay, I just went through your syllabus. I just had a just turn the pages. So I observed it is little bit extended version. Okay, compared to 18 scheme. Okay. So and remaining everything remaining thing as it is. Whatever it is there, it is everything is covered. 17 scheme. Okay, so 18 scheme is the reduced version of 17 scheme. So in the next class, we deal with next module with new concepts.